Right. I said it before, we're very grateful to be here today to talk about what we are doing at the tools department at Sony Mobile. And today we'll talk about how we are using open source to create what we think is a world-class continuous integration tool chain at Sony. Does anyone recognize any of these logos? Wow! Nice. Surprised. First, there are some acronyms we use a lot. Let's take a look at the definitions. SCM, Source Code Management. It's a system that allows sharing and collaboration around source code. Like CVS, Subversion, Perforce, and in our case Git, which we use. It's pretty much the only SCM we use at Sony. CI, continuous integration. It's a development practice where you try to integrate code as often as possible. Small commits, small deltas, and that means isolated errors. And it also means that we're using an automated building and testing system. Every single commit needs to be built and tested before it ends up in one of our main branches. This means that we can detect errors early when they are the least expensive to fix. So, who are we? Yes. My name is Gustaf Lundh. I'm the team lead for the SCM&CI team at Sony Mobile.
And I'm Sven, Selberg, developer in the same team.
So we are a very small team. We are 5 persons, but we have a huge responsibility. We're responsible for all the SCM&CI tool development, among many other tools too. And we do third-line support for these tools. It was our team that was, when we switched to the Android platform, our team was responsible for the wide rollout of the CI solution we have built upon Garrett and Jenkins. And we love open source. We love it so much that we have a huge banner next to our desks at the office. So what can you expect from this presentation tonight, this evening? We'll take a look at our setup and how the workflow looks from the end user's perspective, the developers. We'll talk about open source, why you should use it, and not only why you should use it, but why you should contribute back to the communities. We'll talk about these communities and how you can actually contribute. And then we'll take a closer look at the Garrett and Jenkins communities, which differ quite vastly between each other. So first, the first part, important part in our system is Garrett. It's our source code management system. It's developed in Java, and of course it's open source. It acts like a Git daemon, but it has some extra features. 2 of them is extra important for us. The first one is access management. Using Garrett we can control who can see projects, who can do what down to branch level. For instance, who can see a project, who can see a branch, who can merge code, who can upload code, and who can vote on code reviews. And of course, that's the next important part, code reviews. We are using, Garrett is one of the best code review systems in the world. I just want to state that. I really love the code reviewing functionality in Garrett, and I compare it to a lot of code review tools. Practicing good code review increases our code quality, because it doesn't matter if you have 50 years of development experience. Every developer makes mistakes. That's a fact. And by doing extensive code reviews, we can catch these errors as early as possible, as I said, when they are the least expensive. But the most important part for me is the knowledge transfer aspects. Not by using Garrett, it reinforces a team to be aware of what happens in a huge, complex code base. Every team member needs to review the code that his team member uploads and discuss around it. So it's a very transparent and open way to discuss the code changes. And it's a great way for senior developers to transfer their knowledge about a very complex system to a junior developer that cannot possibly know all the pitfalls and all the knocks and pieces of a very large system. So how do we decide when a code review is completed? Well, we enforce a voting system in Garrett. And I will try to explain the different kinds of votes. But we have set up the voting rules to match our workflow, which Sven will talk a bit about later on. The first kind of vote you can give is a code review vote. It starts at, it's a score you give that starts at -2. -2 is not very common, but it means this can never ever be merged. Whatever happens, whatever you do with the code, this will not enter the code base. It can happen, for instance, if a feature is the scope that should never be added to a product or something like that. The next one is -1. This is the most common score you can get, probably. It means that we have found something you need to fix. It could be styling errors or logical errors. Fix it and upload a new revision. And then we continue. 0. This means that I really don't want to give a score. I just have questions. I don't know if the code is wrong. I don't know if it's right. I need some answers. +1. If I give you +1, it means that the code looks good to me. I don't perhaps have the experience to approve the code for being merged, but or even the access rights to give you +2, which is the final score from a human perspective. The +2 is usually the architect, the Sony, that gives, and then the code can be merged. Well, after you get also a verified score. Verified cannot be given by human; they are given by machines. So every time you upload a change to Garrett, the machine will see that, download the code, analyze it, and test it. If it doesn't build, test fails, or find bugs or query to something finds an issue, you get the -1. You can't be merged until you get the +1. But if everything works, the code builds fine, you'll get the +1 verified. Of course, you need 2 scores to make this work. You need a +2 from a human and +1 from a machine. Alright?
So we're going to take a quick look at the interface that the developer interacts with Garrett. First of all, Garrett is a Git daemon, so you use Git to upload code to Garrett. Those of you who are familiar with Git but not with Garrett, you find this reference rather strange. It should say refs heads if you have a namespace for branches, but refs 4 is a Garrett namespace that works like an API. It says, it tells Garrett that this revision is meant to land on the master branch, meant to be uploaded as a change towards the master branch. And in the output you get from this command, it's called the magic ref in Garrett lingo. In the output that you get from this command, you also get a nice URL, which is the URL to the Garrett UI. We'll take a quick look at the Garrett UI, since that's where the code review happens. Now, don't try to read any of this. I'm just going to give you a quick overview. In the middle here, you have change-related information, which is which project and branch is this change supposed to land in, who are the reviewers. That's also where you add reviewers. Down here, you have the audit log, which records everything that happens in this change, every vote that is made, every build that is started, every comment that is made. So you can follow the life of the change right there. A change consists of one or several revisions as the code review workflow goes around. And you can select which revision you want to look at right now. The revision part of the change, the part of the revision you just selected, is down here on the left side. You have the commit message, you have the ID to the commit and the parent, the SHA-1s, and you also have the file list. The file list contains all the files that this change has touched. So it's a good way, it's a good starting point for a review. You get a feel for which part of the code has been touched and how big the change is. And entering one of those files in a side-by-side view could look something like this. Try to make it bigger so you can see anything, something. But in a very quick glance, you can see what has been changed, what has been deleted, what has been added. And not also that, maybe you have already made this code review on the 4th patch, that's a revision of this change, and you don't want to see all the change, you just want to see what's happened between when you reviewed it the last time and the latest revision. So you can set what diff you want to look at right up here. If you want to make a comment inside the code, you just you just do that. Normally you don't get nice comments like this. You get why in God's name. And you go through the code and you comment what you feel is strange. And when you're ready to set a grade, you go back to the change screen. You press reply, which sets to where you can set your grades and maybe set a comment for the whole change. And also publish all the comments that you've written throughout the review. And that's the main interfaces that a developer sees of Garrett. We're gonna go through Jenkins quickly, if I can hit the right key. It's our build system, as you might suspect. In the CI chain, it listens to changes in Garrett. It downloads those changes and builds, tests, and analyzes the code. It's in a master-slave kind of setup where the Jenkins master owns the build configurations and then starts tasks on the various build slaves. And of course, as we're going to state probably one more time, that Jenkins owns the verify vote. Jenkins is the only one who can set verify +1 and send the change rocket into the merge circle. Now, the developer's interface towards Jenkins is rather complex. This is a project dashboard where you can see where all the different stats and the successful builds, failed builds. Going into a build configuration would take forever, since you can configure a build any way you want. And Jenkins is very plugin heavy, so almost everything you see here is a plugin that's so. Going through the code review verified workflow in a more abstract fashion. It starts with the developer writing code, right? And when the developer uploads that code as a change in Garrett with the object to in the end get merged into the code base. Now, to be submitted, as Gustaf already stated, you need a verified +1 by Jenkins, and you need a code review +2. In our case, at least, you can define any rule you want for merging in Garrett. And what the persons who have the right to set +2 code review are the sub-architects. And the sub-architect is someone who has responsibility for a part of the code base, and for that code to be in main condition. But as you're going to see, there's a lot of revision coming in every day, and we would have to have a lot of sub-architects if they were to review every revision. So before sub-architects want to take a look at your code, you probably need first a code review +1, which you can get from a peer review, a member of your team or colleague that looks through the code and thinks this is good enough. And if he doesn't, then you're back to the drawing board. But this is a happy flow, so we get a +1 here. And the verified +1, as we stated earlier, is Jenkins' job. Now, before Jenkins will give you a verified +1, it will download, build, test, and analyze all the code. And once that is done, and you have, if you are unsuccessful here, then you're sent back to the drawing board, upload a new revision, but we get a +1 here. So then it's up to the sub-architect, and as the same thing goes there, he or she can set -1, and if it's +2, then we made it. So we reached our goal. Now this is from a high-level code review or a perspective. Our team works mainly with a lot of our work is integrating the system to make this part work, because Jenkins needs to know what's in Garrett, and vice versa. Garrett needs to know what Jenkins thinks of a change. So here's another workflow for you. It all starts with the developer downloading code to make changes. He does that from a Garrett slave. A Garrett slave is a read-only replica of the Garrett master, and he uploads as a change to Garrett. What Garrett does then, he replicates this new piece of code down to the Garrett slaves and sends a message to Jenkins that there's a new revision in town. Is this something you want to build? And on the receiving end of Jenkins, you have a plugin called the Garrett Trigger. And it's been written and contributed by Sony Mobile. We are proud. And what Garrett Trigger does, it enables builds to configure that they want to subscribe to a certain branch and a certain project. If anything is uploaded that wants to be merged into that branch, then trigger me. I want to build the software and run my tests. So the Garrett trigger has now triggered a lot of builds in Jenkins, and Jenkins starts these builds on the build machine, so Jenkins slaves. The Jenkins slaves in turn starts to clone from the now updated Garrett slaves and builds the software, run their test, analyzes, etc., and report the result back to Jenkins. Jenkins then aggregates the result of all the triggered builds, and from this it's concluded if this is if everything works, if it has a verified +1 or verified -1, and sends that information back to Garrett. So there's a lot of code flying around, and there's a lot of information that has to go to the right place at the right time. That's our main job.
So let's take now that we know the full workflow, let's take a closer look at the systems. So there is a lot of uploading and downloading and coding going on. In our Garrett instance, we have 6,200 projects. Not all of them active, but the majority are. And since we switched to Garrett during our Android era, our developers, this is 2009, so since 2009 our developers have uploaded 1.2 million changes. Now, as you know, change goes through several revisions, but some changes go through 30, 40, 50 revisions, but the average per change is 2 revisions. I've even seen 99 revisions on one change, never 100. A bit annoying. So we see, this means that we see 200 to 300 revisions per hour during office hours. And all these code changes need to be built and tested. That's a lot of building and testing and reviewing. To handle all this load, we have one Garrett master and we have 25 Garrett replicas, Garrett slaves, spread out all over the world to get as close as possible to the developers. That's also spread out all over the world. And all these slaves are fronted by a load balancer. So when a developer or a build machine wants to download code, he's just asked for the quickest machine available and will get that machine, ensuring that the developer don't spend unnecessarily time downloading code. So, yes, that means that we do a lot of the building in Jenkins. How do we manage that? Well, when we deployed Jenkins from the very beginning, we decided that this should be managed by the users. Let's see what they can do if they get free access to create, execute, and delete build configurations, and even listen to any changes they want in any gig. And this is kind of cool, because this means that if I'm developing an application and I have dependencies to an API or another application, I can set up a job with a test suite that runs on my application, and I can listen to another dependency, another git. So I can say that whenever he does changes, I want my application to be built with those changes, and I want these test cases to be run, and I want my votes to count in the code review. So this means that nobody can mess up my application by destroying my dependencies. Of course it happens, but the possibility is there, and I've seen many teams set it up this way. And of course, people set up all kinds of jobs, and once a guy set up a job to correct spelling errors in commit messages. So it's just creativity to help getting better code. To handle this, we are running a highly customized version of Jenkins. We are running 70 plugins for code static analysis, visualization, connecting to Git and Garrett and so on. Many of them we have written ourselves and contributed to the Jenkins community. And we'll talk a little bit more about this. But all this means, all this building and all these code changes, this means that we build 15,000 builds daily. And these 15,000 builds runs 500,000 to 1 million test cases every day. This of course means that we need a lot of machines building stuff. So we have 1,600 machines in various forms and sizes, and pizza boxes, you know, and desktop computers to be able to shun through all these buildings. Most of them are hosted by our IT department, but we have another type of build machine. It's called a team slave. And this means that it's a building machine that is owned by an individual or a team. Anyone can take a desktop computer, connect some prototypes, a tablet prototype, a phone prototype, connect it to the machine, then call us, send us an email and say, can you connect this to the build cluster? Now this developer can ensure when any one of his team members upload code to Garrett, Garrett notifies Jenkins, then notifies his machine to download that code, build it, flash it onto his phone, and run the actual test cases on the phone, on this prototype hardware, where it's supposed to end up in the future. This is really cool. Of course, 15,000 builds. Some of them are huge download. Platform builds are now around 10-15 gigabytes downloads. We could, of course, our network can't handle all these downloads. We need to solve that. And we solved it. Reference mirrors. Does anyone here know what a reference mirror is in the Git world? Right. A reference mirror is a local copy of a Git. In our case, we analyze all the Git traffic and find out which Gits are the most active. Then we take the most active Gits, places them as local Git repositories on all these 1600 build machines. So when a huge build now starts, 10 gigabyte build, it will first fetch as much code it can from this local copy on the local disk, and then we'll only go out and fetch the small delta that is left from one of the Garrett slaves. It's just that much left. This way we can really bring down the build times, which is important because we want short turnaround times. And then all these mirrors and all these slaves, we create a service which we call Mirror Creator. It runs nightly, ensures the health of all the mirrors on all these slaves. So in one way you can say we're running 1600 Garrett slaves, but not really. So open source software. Why do we use open source software? Well, free does not hurt. It's very easy to motivate for the company that it's free. Companies love free stuff. To be honest, in the beginning it started with Garrett because we wanted to be as close as possible to the Google toolchain, and they use Garrett for their reviews. And that's just the way it started. We loved open source and we love to contribute back to the communities. Now pretty much everything in our tools department is open source. This is one of the most important reasons for me. If we run into a showstopper bug in our source code management system or our build system, everything stops. You cannot deliver code, you cannot deliver binaries for new versions of the software, nothing. By using open source, we can find that bug, we can fix it, we can create a hotfix, and we can deploy it in a production environment. It's sometimes in less than 1 hour. If we were to use closed source software, we have to wait 8 hours for a company in San Francisco to wake up, then try to explain it over phone or over email, then they won't needed to fix the issue without full access to our infrastructure. And then we could only wait a few days and hope that they fix it. Of course, we cannot afford that. By using open source, we can fix our own problems when we need to fix it. So shorter turnaround times, higher uptime, extremely important for us. And also, as you can see, we are scaling our system hugely. Lots of traffic, lots of building, lots of source code. By utilizing open source, we can profile these systems. We can see exactly where our system spends its time. And we can not only fix the infrastructure, we can actually fix the application to perform as good as possible in our infrastructure. Of course, we contribute everything back to the communities. If we fix a performance issue, all companies, Qualcomm and everyone gets the fix. Alright. And so for us, contribution is always the goal. Whenever we start working on a new feature or bug fix, we ask ourselves, will this be accepted by the community? So, why do we contribute? Of course, contributing gives influence. The more we contribute, because communities are a meritocracy, The more you contribute, the more they listen to your voice, the more chance you have to get invited to hackathons and affect roadmaps. And when we create something new from the beginning, for instance, the Garrett Trigger plugin, which is now very popular among other tech companies, we get lots back. So we contribute a Garrett Trigger plugin. Now the vast majority of all features and bug fixes we get are from other companies and individuals. We just can sit back and enjoy everything they do. They do the work for us. This is stuff we would have to do. Now we get it for free just because we contributed the initial little code base we had. Really cool stuff.
Talking about a little more about the two open source communities, Garrett and Jenkins. Starting with Garrett. Now Garrett has a setup with 8 core developers. These core developers come from companies like SAP, Google, Qualcomm, and we also have one of our own in Sony Mobile, David Pershouse. And these 8 core developers have exclusive submit and merge right. So every piece of code that goes into Garrett has to pass one of these 8 individuals. Now this means that there's a very narrow chain of trust, but it also means that the contributions can get stuck. You might upload a change with a feature that you think is so cool, but you won't get it merged until 4 weeks later because none of the core developers has time to look at it because there's something else burning, and they have to make a living as well. The release of Garrett is done on a best effort manner, so that means that when the code base is good enough and one of these 8 core developers have the time to create a proper release, then Garrett is released. Then you will see that this differs from Jenkins' approach. And there's 2 or 3 major releases of Garrett each year. Now one of the cool things about Garrett is that they host official hackathons, as Gustaf talked about. Now a hackathon is a group of developers gathered in one room and just doing code for 5 days. And it's a great way to, these are the core devs, of course. Dave's out, but you get the picture. This is a great way to get closer to the community and to get to know these persons in person that you discuss code with practically every day. It's also a great place to get larger features done for the communities and if you want to have something if you have something that you're stuck with in this room, then you probably have the guys who wrote the code in the first place that you can just tap their shoulder and ask them why aren't these tests passing? Why isn't it happening the way I want it? And they know you have the right persons in that room. As I said, 5 days with nothing but code. Who wouldn't love it? And Garrett is also issued under an Android open source project license, which is a bit restrictive. If you want to contribute, your legal department might want to hear more about it. So let's hear about Jenkins.
Let's compare this to the Jenkins community. It's a very large community. We will speculate a bit about why later on. This is interesting compared to the restrictive nature of the Garrett community. Everyone in Jenkins community can push and merge to both the core and all plugins, even though it's someone else's plugin. You just have to ask for it. I think they even trying to automate so everyone can push everywhere. So with all that great power comes great responsibility. The thing is, it works. People are mostly responsible about this. It's crazy. There are several hundred developers and everyone can do what they want, but it works really well. The thing about this is that sometimes nobody looks at your code. Perhaps it's a plugin and the original author moved somewhere and don't use computers anymore. This way we can actually get the showstopper fixes into that plugin if we don't get the response within a reasonable time. So I think it works. Of course, mistakes happen, and we have seen some pretty bad ones too in the community, but it's a helpful community, and they usually get together and fix those mistakes together. So they have time-based releases. Every week they release a new version, and then you have long-term support releases every 12th week, which is great because we can plan our upgrades around these releases. I think we see this large community because of the plugin ecosystem. it's quite interesting when Kuske, who created Jenkins, working at Sony in this time, started working on Jenkins. Every time he added a new feature, and there are lots of features, he instead implemented it as an extension point for a plugin, and then implemented the extension point instead. This means that everything in Jenkins can be modified, extended, or removed pretty much. So I think this means that a lot of developers who didn't dare to work on the core could create a plugin and modify everything anyways. And when they started working on all these plugins, and there are hundreds and hundreds and hundreds of plugins, the step towards the core was very small. And I think that's how they built this huge community. And it's extremely focused on conferences and being inclusive to all the devs and users. Extremely friendly community. Sony has contributed with sponsorship and quite a few presentations. Last time we sent Robert Chandel to the Jenkins user conference. Now he's working together with the Jenkins creator at CloudBees. And it's an MIT license, which company usually like. The legal departments are usually quite accepting of this license. So to summarize all of this, Garrett and Jenkins, for us it's a very strong combination. It works, it scales. Open source works for us, it works great for us. Contribute back, see it as an investment, you will get it back 10 times over. But it's important, and as we showed with the Jenkins and Garrett communities, they differ quite vastly between them. So try to understand the dynamics of the community. It's okay to learn for a while, because all communities has its own way of working. And I just want to mention there are a lot more to do than just contribute code changes, which can be a bit scary in the beginning. Communities love when we contribute documentation changes, help out with the bug reports, answer questions in the mailing lists, or doing code reviews. In Gary community, we usually say the more boring work you contribute, the more appreciated it is. So, any questions on the continuous integration system at Sony? Right.
Everything was crystal clear.
So what happened to the -2 votes? Is it the -1 votes go back? Do they get sorted out and locked away? Or?
Changes have quite a few states. One of those states are abandoned, and they end up in cyberspace somewhere.
And they lose their job?
No, they don't, because all people get an abandoned change at some time.
And if it's a plus, do they get a bonus?
I wish it was that way, but not for Sony. Perhaps at ClickTech. All right. In that case, one more question.
What's your view on GitLab in comparison to Garrett?
Oh, what a great question, because we are actually running GitLab too. So we are using Garrett for our core, business core, production code development, for instance, all Android code and such. But me, Sven, and the rest of the team set up a GitLab server, which we just opened for every developer, and even at other companies too. We just said, here's a server, you're free to create your own project, get creative, share your stuff. And a lot of people had stuff, they wanted to share scripts and ideas and stuff like that. If it's their own stuff and the scripts and like that, we don't enforce these testing rules and stuff like that. We want that for our phones because we want you to have great phones. But their own personal projects and project that helps them manage their stuff, they are free to create projects at their own will.
All right.
All right, great question.
Thank you.